Hello, and welcome to our section on how to get started with data warehouses in Microsoft Fabric. In this section, we will describe data warehouses in Fabric and compare and contrast a data warehouse versus a lakehouse. We'll also create and manage fact tables and dimensions and show how to work with the data warehouse here in Fabric and more. Microsoft Fabric enables data engineers and analysts to ingest, store, transform, and visualize data all in one tool with both low-code and a traditional data warehouse experience. Fabric's data warehouse is a relational data warehouse that supports full transactional T-SQL capabilities. It's a fully managed, scalable, and highly available data warehouse that can be used to store and query data. Using the data warehouse, you're fully in control of creating tables, loading, transforming, and querying data using either the Fabric portal or T-SQL commands. Note a few of our data warehouse fundamentals listed here. Data ingestion into the warehouse can also be done many ways. We will highlight two of those ways coming up in a later section, as both data pipelines and Dataflow Gen 2 can be used. Data storage for the data warehouse is on OneLake in the Delta Parquet format, so it's optimized for changes and for big data analytics. You can use SQL to query and analyze the data, or use Spark to process the data and create machine learning modules. Data warehouses in Fabric facilitate collaboration between data engineers and data analysts, working together in the same experience. Data engineers build a relational layer on top of the data in the lakehouse, where analysts can use T-SQL and Power BI to explore the data in the lakehouse or the data warehouse. The OneLake architecture is designed to unify storage for lakehouses and warehouses, enabling seamless access to data without duplication. This architecture is centered around a single data lake, which fully supports T-SQL and utilizes the Parquet file format for efficient data storage and access. OneLake architecture centralizes all storage into a single data lake. This approach ensures that all data, whether structured or unstructured, is stored in one location, simplifying data management and access. It offers unified storage where all data is stored in a single repository, reducing complexity and improving data governance. The data can be accessed by various services and applications without the need for duplication, and the data lake can scale to accommodate large volumes of data, making it suitable for big data analytics. Synapse Analytics is the engine that powers the OneLake architecture. It provides integrated analytics capabilities, combining SQL-based data warehousing with Spark Big Data Analytics into a single service. It seamlessly integrates with various data sources and services, enabling comprehensive data analysis with high-performance queries and data processing. OneLake architecture fully supports T-SQL. This ensures that users can leverage their existing SQL skills to interact with the data stored in the lakehouse and warehouse and to query and manipulate the data. It also supports complex queries and data transformations using T-SQL. The Parquet file format is used for storing data in OneLake. Parquet is a storage format that is highly efficient for both storage and query performance, reducing the amount of data read during queries and improving performance. Parquet files are highly compressed, reducing storage costs and widely supported. Notice that OneLake supports the data warehouse, the lakehouse, the KQL database, the Power BI dataset, and more in a workspace for united management and governance. To create a data warehouse in Microsoft Fabric, you can use the Fabric Service portal at app.fabric.microsoft.com and navigate to or create a workspace assigned the Fabric capacity. Next, click on the plus new item and choose Warehouse from the list. Next, provide a name for your warehouse and click Create. The data warehouse is built for you and ready for you to ingest data into it like you'd like to. You can start with a blank warehouse or you can use sample data to get started quickly. It's also seamlessly integrated with other Fabric services for data ingestion and analytics. Designing a data warehouse involves structuring your data into fact tables and dimension tables. This approach helps organize data for efficient querying and analysis. Fact tables contain the quantitative data that you want to analyze, such as sales figures, transaction amounts, or performance metrics. Fact tables also typically have a large number of rows because they store detailed transactional data. These tables are the primary source of data for analytical queries. Fact tables have the number that you'd like to calculate and the foreign key to the dimension table's primary key. Dimension tables, on the other hand, contain descriptive information about the data in the fact tables, such as product details, store locations, or customer demographics. Dimension tables typically have fewer rows compared to the fact table because they store categorical data. These tables provide context for the numerical data in the fact tables, enabling more meaningful analysis. Define relationships between fact tables and dimension tables using the dimension table's primary key and the fact table's foreign key. A time dimension table is crucial for enabling data analysis to aggregate data over various temporal intervals. This table typically includes columns that represent different aspects of time, such as year, quarter, month, week, and day. By using these columns, analysts can perform time-based analysis, such as tracking sales trends over months or comparing quarterly performance. Time dimension tables allow for aggregation of data over different time intervals, like monthly sales, quarterly revenue, etc. It facilitates trend analysis by providing a structured way to examine data over time. It also enables filtering and grouping of data based on specific time periods. Slowly changing dimensions are significant in a data warehouse because they enable users to analyze and understand changes to data over time. These dimensions ensure that data stays up to date and accurate, which is imperative for making informed business decisions. There are several types of slowly changing dimensions, each handling changes a little bit differently. I will discuss just a few here. In type 1 slowly changing dimension, changes to dimension data overwrite the existing data. This method does not keep a history of changes. This is easy to implement, manage, and always reflects the current data. In type 2 slowly changing dimensions, changes to dimension data in the creation of your new row. This method keeps a history of changes by adding new rows with versioning information. This maintains a history of changes, allowing historical analysis and providing versioning information to track changes over time. In type 3 slowly changing dimensions, changes to dimension data result in the addition of new columns to store previous values. This method keeps a limited history of changes and is suitable for scenarios where only recent changes are needed. In type 4 slowly changing dimensions, a separate historical table is created to store the history of changes. The main dimension table contains only current data, while the historical table keeps track of all the changes. In most transactional databases, or OLTP, also known as online transaction processing databases, these are used in business applications. The data is normalized and is usually in third normal form to reduce duplication. In a data warehouse, however, the data is generally denormalized to reduce the number of joins required to query the data for OLAP, or online analytical processing. The data warehouse is organized as a star schema, and this is a common design pattern used in data warehousing to optimize query performance and also simplify data modeling. The fact table is the central table in the STAR schema that contains quantitative data for analysis. Dimension tables are arranged around the fact table, forming a star-like pattern. Each row in the fact table can be associated with multiple rows in the dimension table for a one-to-many relationship. Dimension tables are arranged around the fact table, forming a star-like pattern. For each row in the dimension table can be associated with multiple rows in the fact table for a one-to-many relationship between the dimension table's primary key and the fact table's foreign key. I'd like to highlight a few benefits of the STAR schema. First, it helps to simplify queries, making them easier to write. 2, it provides efficient query performance due to its denormalized structure. And 3, it is suitable for large data sets with fast and efficient data retrieval and analysis. To visualize a STAR schema, imagine the fact table at the center with lines connecting it to each dimension table, forming a star-like shape. Notice here our central fact sales table that has the numbers to be summarized and the foreign keys that relate back to our dimension tables: dim date, dim product, dim customer, dim store, dim employee tables. Note too that our dimension tables have the attributes that we can use to filter and group the numbers in our fact table, along with the primary key for the one-to-many relationship with the fact table. The dimension table's attributes, or fields, can also group together numbers in the fact table at different levels through creating a hierarchy. For example, you could find the total sales revenue for a whole region, or for just one country, or one state, or one city, or even just one customer. The information for each level should be stored in the same dimension table. A snowflake schema is a type of data model used in data warehousing and in business intelligence. It is an extension of the STAR schema where dimension tables are normalized into multiple related tables. This result is a more complex structure due to the additional tables and additional relationships, but can lead to better data organization and reduced redundancy, which can save storage space. A snowflake schema has fact tables and dimension tables, just like the STAR schema, but it also includes normalized dimension tables that are further broken down or split into multiple related and smaller tables to eliminate redundancy. These normalized dimension tables are organized in a hierarchical manner, reflecting real-world relationships. If there are lots of levels, it may make sense to use a snowflake schema, as shown here on the right. The dim product table has been split up or normalized to create separate dimension tables for product categories and suppliers. Each row in the dim product table contains key values for the corresponding rows in the dim category and dim supplier tables. Also, a dim geography table has been added, containing information on where customers and stores are located. Each row in the dim customer and dim store table contains a key value for the corresponding row in the dim geography table. The snowflake schema is suitable for large-scale data warehousing environments where data normalization is crucial. It's suitable for generating detailed reports with hierarchical data. It's also efficient for ETL or extract, transform, and load processes due to its normalized data structure. However, query performance can be slower due to multiple joins. It may also be more difficult to maintain and update due to the normalized structure. However, it is well suited for environments where scalability and detailed reporting are critical. To ingest data into a data warehouse, you can leverage various tools and features provided by Microsoft Fabric, like pipelines, data flow Gen 2, cross-database querying, and the copy into command. Pipelines are used to orchestrate and automate data workflows, including data ingestion, transformation, and loading into a data warehouse. It offers rich out-of-the-box data orchestration capabilities to compose flexible data workflows that meet enterprise needs. It offers also lightweight complexity and transformation like conversion, column mapping, merging and splitting files, flattening the hierarchy, and more. It has over 30 sources that it can connect to and 18 plus destinations. It can handle a low to high data rate volume size for ETL using T-SQL or JSON. It offers easy to use wizards and a canvas too with low to no code necessary. The pipeline can include both Dataflow Gen 2 and notebooks as activities and can be run on demand or on schedule. Dataflow Gen 2 allows for scalable and efficient data transformation and movement. It's designed for data ingestion, transformation, wrangling, profiling, and more. Dataflow Gen 2 can handle data volumes from low to high and includes over 300 plus transformation functions, including 150 plus source connectors. It uses a graphical version of the Power Query online editor, similar to the Power Query editor from the Power BI desktop, in a no-code to low-code environment where you can use it for ETL and work with the M query language and T-SQL. Cross-database querying allows querying data across multiple databases, enabling seamless data integration, consolidation, analysis, and a unified view of data from multiple sources. However, performance may be impacted due to cross-database queries. The copy into command is a powerful and efficient way to load data into a data warehouse in Microsoft Fabric. It allows you to bulk load data from various sources such as CSV, Parquet, and JSON files in the Azure Blob Storage and etc. into tables in your data warehouse. This method is particularly useful for scenarios where you need to ingest large volumes of data quickly and efficiently. It is simple to use and implement with straightforward syntax. Each method of data ingestion has its own strengths and weaknesses, and the choice of your method depends on the specific requirements for the data warehouse and the use cases it needs to support. Generally speaking, pipelines are ideal for automating workflows. Dataflow Gen 2 is optimized for large-scale transformations. Cross-database querying provides unified access to data, and the copy into command is efficient for bulk loading. You can create zero-copy table clones with minimal storage cost in a data warehouse. These clones are essentially replicas of the tables created by copying the metadata while still referencing the same data in one lake. This means that the underlying data stored as Parquet files is not duplicated, which helps in saving storage costs. Clone tables are particularly useful in several scenarios, like development and testing, where you can clone, which will allow your developers and testers to create copies of tables in lower environments, facilitating development, debugging, testing, and validation processes. Use clone tables in data recovery. In the event of a failed release or data corruption, table clones can retain the previous state of the data, enabling data recovery. And use clone tables in historical reporting. They help to create historical reports that reflect the state of the data at specific points in time and preserve data at specific business milestones. When querying data in Microsoft Fabric Data Warehouse, you can leverage various tools and features to enhance your productivity and efficiency. The SQL Query Editor in Microsoft Fabric provides a comprehensive set of features that enhance productivity and streamline the query development process. IntelliSense, code completion, syntax highlighting, client-side parsing, and validation are all some of the key features that will help you write accurate and efficient SQL queries. Additionally, the integration with Copilot offers advanced AI data-driven capabilities to further simplify and automate database management. Using SQL Server Management Studio, or SSMS, or the Azure Data Studio are powerful tools for managing and querying your databases. SQL Server Management Studio is a comprehensive tool for managing SQL Server databases, offering advanced features for data administration, development, and querying. The Azure Data Studio is a cross-platform database tool that provides a modern, lightweight, and extensible environment for data professionals. It supports SQL Server, Azure SQL Database, and other data sources. IntelliSense is a feature that provides real-time code suggestions like keywords, table names, column names, and functions based on the context of your query and code completion as you type. It helps you write SQL queries faster with fewer errors by offering context-aware suggestions. Syntax highlighting visually differentiates various elements of your SQL code, making it easier to read and understand using different colors to highlight SQL syntax elements and improve readability. Client-side parsing involves analyzing and validating SQL queries on the client side before they are executed on the server. This helps catch syntax errors early and ensures that queries are syntactically correct and conform to SQL standards and best practices. Lastly, validation checks the correctness and integrity of your SQL queries. It ensures that the queries will run successfully and produce the expected results. The Visual Query Editor in Microsoft Fabric provides a no-code experience for creating and managing queries against data in your warehouse. This tool is designed to simplify the query creation process by allowing users to visually manipulate data through drag and drop actions and intuitive transformations. To create a visual query, click, hold, and drag the table to the canvas. Then you can make the needed transformations like manage columns by selecting columns to include or exclude from your query to help you focus more on relevant data. You can use filter rows by applying filters to rows based on specific criterion to kind of narrow down the data set to include only the rows that meet the criterion, like filtering rows where the amount is greater than 100. You could also use replace values within columns to clean and standardize data by replacing incorrect or inconsistent values, like replacing null values in the customer ID column with a default value. Use group by to group data by specific columns and to apply aggregate functions. You can summarize data by grouping and aggregating, which is useful for reporting and analysis. You can also use additional features like merge queries to combine data from multiple tables into using join operations. Or you can use expand columns to include specific fields from related tables. Or consider using save as view to save your query as a view for reusing it later and for data loading. Or download query results in various formats such as Excel, JSON, or CSV. Or even create reports and visualizations based on query results. The Visual Query Editor in Microsoft Fabric provides an intuitive and powerful way to create and manage queries without writing code to efficiently analyze and manipulate. This tool is ideal for users who prefer a visual approach to data querying and transformation. Building relationships in Microsoft Fabric Data Warehouse involves several steps to ensure data is properly connected and accessible for analysis with careful planning to optimize for performance. Use foreign keys to establish relationships between tables. A foreign key in the fact table points to the primary key in the dimension table. To build relationships in Microsoft Fabric Data Warehouse, use the model view in the Fabric portal and select the data warehouse you're working with to visualize and manage relationships between tables. Also, ensure each dimension table has a primary key that uniquely identifies each record, and then identify columns in the fact table that will act as foreign keys to establish relationships with other tables. To create a relationship, drag and drop columns from the dimension table's primary key to the fact table's corresponding foreign key. Using the model view in the Fabric portal simplifies the process of building relationships between tables, giving you a very efficient way to establish and visualize relationships. Microsoft Fabric automatically creates a default semantic model for Power BI users to facilitate report creation. The semantic model is designed to simplify data analysis and visualization by providing a structured and user-friendly representation of the data warehouse. When you connect your data warehouse to Power BI, Fabric automatically generates a semantic model that includes tables, columns, relationships, and measures. This model is designed to be intuitive, allowing users to easily create reports and dashboards without needing deep technical knowledge. Consider shaping the semantic model appropriately to minimize the need for complex transformations later in the reporting process. This involves cleaning and structuring data at the source. Ensure columns have descriptive and user-friendly names. This makes it easier for report creators to understand the data without needing to refer back to the documentation. Consider hiding columns that are not needed for reporting to reduce clutter and improve usability. Similarly, hiding entire tables that are not relevant to the reporting needs. By leveraging the default semantic model in Microsoft Fabric and shaping it to suit your needs, you can create a more efficient and user-friendly data environment. Likewise, hide entire tables that are not relevant to the reporting needs. By leveraging the default semantic model in Microsoft Fabric and shaping it to suit your needs, you can create a more efficient and user-friendly data environment. Visualizing data in Microsoft Fabric Data Warehouse is a powerful way to gain insights and make data-driven decisions. While this task may typically fall to data analysts, it's valuable to know that you can create Power BI reports directly from within the Fabric warehouse. After you've logged into the Microsoft Fabric portal, select the data warehouse you're working with. Microsoft Fabric integrates seamlessly with Power BI, allowing you to create reports directly from the data warehouse or from the Power BI by simply connecting to the Fabric data warehouse as a data source. Choose from the various visualization types such as bar charts, line charts, pie charts, tables, etc., and then drag and drop fields into the visualization canvas to create charts and graphs. You can even customize the appearance and settings of your visuals to better represent your data. Ensuring the security of the data in the Microsoft Fabric Data Warehouse is crucial. Microsoft Fabric provides a comprehensive and robust set of security features to protect your data. Role-based access control allows you to control access to the warehouse and its data and assign specific permissions to users based on their roles within the organization. This ensures that users only have access to the data and resources necessary for their job functions. In the Fabric portal, you can manage RBAC settings to control access to the data warehouse and define roles such as admin, member, contributor, viewer, each of which has a different level of access. Users and groups can be assigned to roles. This assignment controls their access to the resources within the data warehouse. SSL, or secure sockets layer encryption ensures that data transmitted between the data warehouse and clients is encrypted, protecting it from interception and tampering. SSL is enabled by default in Microsoft Fabric, ensuring secure communication channels. Azure Storage Service Encryption automatically encrypts data stored in the data warehouse using Microsoft managed keys, or you can bring your own customer managed keys. This encryption is transparent, and it does not require any changes to applications accessing the data. Azure Monitor and Azure Log Analytics provide comprehensive monitoring and logging capabilities to track activities and to detect anomalies in the data warehouse. Set up alerts for suspicious activities and gain insight into the usage patterns and potential security threats. Configure Azure Monitor and Log Analytics in the Azure portal to monitor your Fabric data warehouse. Multi-factor authentication, or MFA, adds an extra layer of security by requiring users to provide 2 or more verification factors to access the data warehouse. You can enable MFA through the Microsoft Entra ID, formerly known as Azure Active Directory, to protect user accounts from unauthorized access. Microsoft Entra ID integration provides identity and access management capabilities, integrating seamlessly with Microsoft Fabric to manage user identities and access permissions. Enable SSO, or single sign-on, for a streamlined and secure login experience. And configure Microsoft Entra ID in the Azure portal to manage identities and access your Fabric data warehouse. Workspaces are containers used to store and group related items like lakehouses, warehouses, semantic models, Power BI reports, and more. Items can be granted individual access with a similar permission experience in OneDrive sharing. You can grant permissions to users via T-SQL or in the Fabric portal. Grant the following permissions to users who need to access your data warehouse. Read allows the user to connect using the SQL connection string. Read data allows the user to read data from any table or view within the warehouse. Read all allows the user to read data, including the raw Parquet files in OneLake that can be consumed by Spark. Note that a user's connection to the SQL endpoint will fail without read permission at a minimum. The admin role can create, modify, and delete all items within the workspace, and the manage users role and permissions. Members can add members or others with low permissions and can create, modify database mirroring items, warehouse items, and SQL database items. Contributors have similar permissions to the member, but can't add other roles with lower permissions. The viewer can view and read Lakehouse and data warehouse data and shortcuts with T-SQL through the TDS endpoint and Lakehouse data through the Lakehouse Explorer. Take time to consider your workspace permissions and review regularly, as data access and roles will change all the time. Now it's time to analyze data in a data warehouse.
Now let's move into our section on Analyze Data in a Data Warehouse. And we are currently in Fabric. And like we begin every lab, we're going to go ahead and make a workspace. I'm going to call this DP-700 Lab 10. And I'm going to verify that this is a Fabric capacity or a trial license that we're using. And here we have our workspace. I'm going to go ahead and add in our data warehouse. and we'll add that in. You can give it any name you'd like. Now, once this data warehouse is created, we're going to go in and start creating tables and adding data to those tables. We'll model it. We'll also go in and run reports off of it, and then, of course, query it. So what I'm going to do is I'm going to go ahead and add in a table. And right now we don't have any tables, as you can see. And the environment looks very similar to what we would have in the SQL Server Management Studio. So what I'm going to do is I'm going to go ahead and add in a query here. And I created a new SQL query, and I'm going to use it to create a new table. And this table is called dim product. So we're creating our first dimension table here in our in Fabric here in our Warehouse Explorer. And then what I'm going to do is I'm going to populate that table with a little bit of data. I'm going to insert about 3 records. I'm going to select this so that we run only this when I click on Run here. And then we'll verify that those 3 records have actually been added. Now I'm going to go into dim product by clicking on it. We'll hopefully see those 3 records added there. That's one way to do it. I can also click the ellipses, new SQL query, and show me the top 100, and you can see the 3 records added. So a lot of ways to do that to verify. What I'm going to do next, though, is I need to make a few more tables, and I would like to populate it with a lot of data. So what I'm going to do is I'm going to use this create DW text file right here from GitHub. I'm going to copy it, and if we take a closer look at it, you're going to note that it's actually going to add about 3 more tables, 2 more dimension tables, and then add in a fact table and a bunch of data. So it's going to take a little bit to process, maybe under 9 seconds. Let's see, right around 9. There we go. Okay, looks good. So now we have those tables, and I can click on a couple of them if you want to see what's inside. So we do have some records out there. You might find this helpful. Okay, so we have records that we have available. And so we've created our 3-dimension tables. We created a fact table. Now what we're going to do is we're going to model it. So let's do that. Let's model it here. And the reason we do modeling is because we want the tables to have a relationship with one another. And if they have a relationship with one another, we can then query from one table to the other. So I'm going to put my fact sales order table right here, and I'm going to create a relationship with it and my dim customer table, and I'm going to do it based on the customer key. So those 2 should match there, and it's the customer key right there. Might have hit the wrong one, but notice it's a many-to-one. So the many side is the fact table, the one side is the dimension table. I'm going to go ahead and set that up. And then I'm going to do the same thing with the date key. We have the sales order date key that we're going to use. It has a relationship with the date key in the dim date table. And again, the fact table is up top, so it's the many side. Has the foreign key. And then the dimension table is the primary key side, so it has the one side. So that looks good there. And then what I'm going to do is set up a relationship with dim product. So I'm going to take the product key to the product key there, and same scenario. Okay, so now we have it modeled. Now, the moment we model this, we can now go in and start querying it. So that's what we're going to do now. I have a little query here that I'd like to run. I'm going to click on New SQL Query. And what I'm going to do is paste this in. I want you to notice that we're doing a querying from the fact sales order table to the dim date table. So we're doing a join between those 2 to extract information about the year, the month name, and then creating a field called sales revenue. So that looks pretty good. Well, we're going to take it a little further here and maybe do a little bit more querying. This time we're going to query for a few more tables. So instead of doing a join between just 2 tables, we can do a join between many tables. So we're going to do a join between fact sales order and dim date, and then between dim date and dim customer. So we're trying to use the relationships that were set up between the tables to run our queries. And you can see it works out well. Now I'm going to tell you the more joins that you add here, really the slower it's going to run. But if you have to do joins, we have to do joins. We want to be able to get the information from multiple tables. So what I want to do is I want to maybe reuse some of these queries. And an easy way to reuse some of these queries is by creating a view. So that's what I'm going to make right here. I have a view called sales. It's a V sales by region. And notice it's going to go ahead and use the join between our fact sales order and then also our dim date and then with customer. So we'll run this query, and what it actually is it's creating a view. So I should go and see if I have the view that's there. Is the view there? We'll refresh it. We should hopefully see it. We'll click the arrow, and there it is right there. So that view is there. And we just put a select statement inside of it so we can run that select statement over and over. Actually runs a lot better in a view. And what I want to do is then use that view. So what we're going to do is I'm going to run a statement here where we're going to query for that view. And in particular, in that view, we're going to query for its calendar year, month name, sales region, and sales revenue. And you can see the field names right through here. We had little aliases where we changed them out. And we're going to query for a subset. So the original view looks like it had about 5 fields. We're going to query for 4 of those fields, pulling it from the view and then sorting it by calendar year, month of year, and sales region. So we'll go ahead and select that. And we'll run our query. And there we have our result. So you can see that you can easily make tables, you can make views, you can reuse those queries in those views. But maybe what you want to do is rather than, writing this out, maybe we want to use it visually. So we do have the option to create our SQL visual query. And that's what we're going to do here. And we're going to work with 2 tables. We're going to work with our fact sales order and our dim product table. Now, what I want you to note is if you just try to do it like this, it's not going to work. And I've had a lot of people try that. How you have to do this is set your mouse on it, click on it, take a little breath, and drag it on over. There it goes. So I've had a lot of people do that. And I used to do it that way, like, oh my gosh, how come this isn't working? And, it's because you have to take your time. You got to click and hold. Once you got it, then you can drag it on over. And there we go. Then we have it. Okay. So just a little help there because I know we might run into that going forward. So what I want to do is I can do a visual query here. Now, this visual query, you can see it shows the source, the database, the table, but I can also add in additional options. So I'm going to click on in this, and you get the little plus there. I'm going to click on the plus. Ton of things you can do query-wise. But what I'm going to do, I'm going to scroll down to the bottom so you can see all the things you can do. There's a lot in here, a lot of math it looks like, and making changes. But what we're going to do is we're going to go ahead and do a merge query. So a merge query, as you know, is equivalent to a join. So I'm going to do a merge query between my fact sales order table and my dim product that I have right here. And I'm going to do it on a particular field. So it has to be a field that they have in common. So I'm going to do it on the product key. So I'm going to make certain the product key is selected here. I'm also going to make certain the product key is selected down here. And once it has that, then it should tell you the different types of joins that you can do. And the join that I want to do is I'm actually going to have it do simply a left join with this, a left outer join. So I'm going to keep that option selected, but I have others. And then notice it shows you what's going to happen. So the selection matches. So all of these match across. Now remember, they have a relationship by the product key, so they should be matching anyway. So I can do the left outer join here. I'm going to click OK. And we get the result down below. So notice how it shows it visually. You can see the result. I could then take a closer look at this, and I have an expander here. So this little expander is an option that lets us navigate through hierarchical data. So it's very helpful for that process, navigating through hierarchical data. You may have seen it out in Power BI because it's there too, but I'm going to click on it. And let me see if I can get that to open. And what I want to do is I could have it show really anything from that product table here in the fact table. But what I want it to show is maybe I'm going to have it show product name only. And that way I could query for product name here in my fact table. And notice it adds what we've been doing here. Now, if you want to make a change to any of these, notice you can set your mouse on it. And if you right click, there's an option to edit the settings. So if you need to be able to do that, there's some editing options there. But it shows you all the steps and it shows them graphically. So we have that added here. And I think somehow I didn't select this maybe because it should change it to product name. And let's see if we get it. There we go. Okay. So I must have got distracted with other things here, looking up at my visual diagram. Okay, so we have that. Then what we're going to do is we're going to visualize some of this data. So to do this, what you need to keep in mind is I can turn this into a table. I could save it as a table if I wanted to, the result, which would be a really easy and fast way to make a table. I could download it into Excel, which is one of everyone's favorite products there. I could also visualize it. And to visualize it will take us out into Power BI. But before I do that, I want to hide a few things because there's a couple fields in every one of our tables here that maybe we don't want people to see for reporting purposes. So what I'm going to do is I'm going to go back into the model layout here. And you may know I now see some additional tables out here. And these are tables that are built in by default for Fabric that give us insights on what's going on query-wise and more inside of our, in this case, our warehouse. So I'm going to scroll over to the right here. And what I'm going to do is I'm going to hide some of these fields. So I'm going to hide our sales order. And notice when I set my mouse on, I'm just kind of hovering over it. I can turn that one off and hide it. Oh, it looks like it's out of sync for a moment here. Let's see if we can hide it. There we go. And then here is the customer. So I want to hide that one, the customer key, and then I want to hide the product key. So those are some of the foreign keys that relate back to our dimension tables. And then I'm going to hide the customer alternate key from the customer table here, and also the customer key from the customer table. And then I'll do the same thing with the date alternate key and the date key here. And then from the product table, I have the product key that I want to hide and the alternate key there for the product table. Perfect. Okay. So now I've set it up where I don't want to, see everything that I shouldn't be seeing here. And when we get into the report, I want to hide it. So what I'm going to do now is I'm going to go ahead and go into reporting. And I'm going to click on new report. And then I'm going to click on continue. And it's going to take our model and pull it into into Power BI for us. So it'll take it a moment there. And then once we're out here, what we want to do is we're going to create a report. So I'm going to go into my fact table. And I want you to notice that it doesn't have the keys that relate back to the dimension tables because those are hidden. But what I want to do here is I'm going to need a number to work with. So I'm going to pick up that sales total right there. Then what I'm going to do is you notice it's kind of a column chart. That's kind of the default when it finds a numeric value. Then I'm going to go up to the dim product table and I'm going to find category. And I'm going to add that in. And I could drag this out to make it look a little better if I like, a little bigger and better. But I want to see this in a different angle. So I'm going to try it like that. Okay, so I could go even more into reporting. And if you're interested in that, that's like a separate class. But what we can do is we can save this and then we can come back to it. So if we wanted to do this, this is essentially my sum of sales total by category. I got one letter missing there. So we'll add that in, and I'm going to go ahead and hit save. Okay, so now the report's saved, and if I go back to my workspace, you'll see my report there I can get back into. There's the model that I created, and there's our warehouse. Thank you for joining us. I hope you enjoyed this session, and looking forward to seeing you in the next.
Now it's time for our knowledge check. Question 1. Which type of table should an insurance company use to store supplier attribute details for aggregating claims? Answer: dimension tables. Question 2. What is a data set in the data warehouse experience? Answer: data sets are semantic models that are used to create reports. Question 3. What is the purpose of item permissions in a workspace? Answer: to grant access to individual warehouses for downstream consumption. To recap, we discussed data warehouse fundamentals and the feature of OneLake. We talked about how to create a data warehouse in Fabric, including the design of the fact table and the dimension table, along with special dimension tables like time and slowly changing dimensions. We also explored the star and snowflake schema and the 4 different ways to ingest data into the data warehouse, along with defining clone tables. We also looked at how to query and visualize queries, along with how to build relationships and work with the default semantic model. Lastly, we gave a brief security overview of some of the security features of Microsoft Fabric Data Warehouse and specific workspace and item permissions. For more information on how to get started with data warehouses in Microsoft Fabric, please see the link here.